this video, we've been asked to solve the following differential equation. We have dy by dx is equal to x squared over y. Now there's lots of different ways of solving differential equations. You have integration factors, you have separation, you can do substitutions. This is a nice simple example though, where we can separate it, then integrate to find the solution to it. The first step in the process of separation is to get all your one variables on one side and all your other variables on the other side. For this example, we're going to take all the x's onto the right hand side and all of our y's onto the left hand side. So let's have a look, see what we should do. Well, I have my x squared already on the right, but I have this dx on the bottom here. So what I want to do is move this dx up to the right hand side. Now mathematically we can't just move it up there, but that's what we're going to do because, well, it will work out and so it will be okay. So let's first of all move that dx up to the right hand side. So let's see what we get. We'll find dy is now equal to x squared over y. And then this dx has gone up there, so we'll have a dx on the right hand side. It's not fully separated though, because we still have a y and x's mixed up with each other on the right. So what I want to do is move this y over to the left hand side. So to do that, I need to multiply both sides by y. And on doing so, the y's will cancel here and here, and it will leave me with a y dy on the left, and on the right we have an x squared dx. It's at this point where we need to integrate. So all I do is put in two integral signs. On the left hand side I have the integral of y with respect to y, and on the right I have the integral of x squared with respect to x. So all I need to do is perform that integration. Let's have a look at the right hand side. I've got the integral of x squared. Now we need to recall that when dealing with powers of x or powers of y, as it will be here on the left, if we say have the integral of x to the n, or any number, when we integrate it, we will get x to the n plus 1 over n plus 1, not forgetting our plus c. Recall this result holds for all values of n except when n is equal to minus 1. And that's a special case. But typically, all values of n except for minus 1, this result holds. Add 1 to the power, divide by the new power. So let's apply that to our equation here. We have x squared, so add 1 to the power will give us x cubed. And then what do? We divide by the new power, so I'm going to divide by 3. So the integral of x squared is x cubed over 3. Don't forget, of course, the constant of integration, so I'll put in my plus c. Let's have a look at the left hand side. What do I have here? Well, I have the integral of y with respect to y. And y on its own is actually just a power of 1. We don't write that in, but it is a power of 1. So when we integrate it, add 1 to the power, divide by the new power, it will be 1 plus 1 is 2, so the new power will be a 2, so it will be y squared divided by the new power, divided by 2. Now we don't bother to include our constant of integration here because we've already put it on over this side, so we don't need to put 2 in. We can just keep the 1 over here. Now this is essentially solved. You may want to rearrange to get y as a function of x. I think I'm just going to find out what y squared is, and I'll leave it at that. So to get y squared on its own, I need to multiply both sides by 2 to get rid of that half here. If I multiply both sides by 2, I'll get that y squared is equal to, now every term here gets multiplied by 2. So it will be 2 lots of x cubed over 3. And then I'll get a plus 2c. Now, a very common thing you'll see in differential equations is people renaming this constant. We've got 2 lots of c, 2 lots of a constant. Well, 2 lots of a constant is still a constant. So, typically, we'll just call that c again, or d, or whatever letter you want to use for your constant. I'm just going to call it d. So I'll write my final answer as y squared is equal to 2x cubed over 3 plus my constant of integration, which is equal to d. And I think I'll leave my answer there. If we wanted to, we could find y by square rooting both sides, but I'm quite happy to leave it as y squared. Thank you for watching.